Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, everybody? Today, inshallah, we're going to finish integration. As you see, the topic is integration by recognition. Simply, this topic is the reverse of specifically chain rule on differentiation. We'll start with the rules first. Integration of g dash of f of x, which means derivative of any function like trigonometric function or any powered function, even e with the len, multiplying by derivative of the function itself, which is f dash of x. The answer is the function of g. So integration of the derivative of any function will back you to the main function again, because when you differentiate the main function, you're going to reach to g dash, the derivative. Okay, for example, that means integration of ax plus b power of n dx. If you have any powered function in differentiation, we reduce the power by 1, and then you multiply by the new power, then multiply by the derivative of what you have inside the expression. Now, in integration, we're going to do the opposite. So what you do first, you're going to find, first of all, the derivative. The derivative of ax plus b is a. And as you see, the a in the denominator, so you need to divide it by the derivative. In differentiation, we'll multiply by the derivative. Here, we need to divide by the derivative. So 1 over a. Then, add the power by 1. Because in integration you have to add the power, and you divide it by the new power. So it's n plus 1 divided n plus 1 divided by the new power. If you have a constant with the integration of k, ax plus b power of n, then you keep the constant as it is, and you do as we did in the previous part. Integration of a, so a, as you see, the derivative, so a divided by a as we did in the previous part, so a will cancel a, so we can write here a divided a, then a cancel a, then just you have to add the power by 1 and you divide it by the new power. We're going to do that on the examples which coming next. Integration of e as well, which has the same idea, integration of e power of ax plus b. So derivative of the power is a, you need to divide it by the derivative, and integration of e will be the same thing as we did in the previous video. As we did in the differentiation of e will be the same thing, e. So divided by the derivative of the power times e itself. Integration of k, constant, any constant which is not related to the derivative. So you divided the constant by the derivative of the power multiplying e itself without any change, plus c. And integration of a, times e power of ax plus b, derivative of the power is a. So as we did in the previous part, a over a, then a cancel a. And integration of e will be the same thing, plus c, because this is definite integration. Here is just some questions from exercise 12c from the textbook, page 267. The question asks you to find integration of 1 minus 2x all to the power of 5. Yes, the derivative of the expression which you have inside is negative 2, because derivative of the 1 is a constant, so derivative is 0, and derivative of negative 2x is negative 2. So derivative is not given in the question. So you divide first of all by the derivative, 1 over negative 2. Then directly add the power by 1. 1 minus 2x power of 6 over 6 plus c, because it's indefinite integration. Just multiply the denominator, so you can write the answer as 1 minus 2x power of 6 over negative 12 plus c, or 1 over negative 12, 1 minus 2x power of 6 plus c. Same idea in j. 4 that you have in the denominator is not related to the derivative of the expression which would you have inside the brackets. First of all, you couldn't integrate or differentiate any expression in the denominator, so you have to move it up first, so that bracket goes up. integration of quarter of x plus 3 power of negative 2 dx, or integration of x plus 3 power of negative 2 all over 4 dx. Yes, derivative of the expression is 1, so divided by the 1 will give you the same thing. So just keep the quarter outside, and here you have to add the power by 1, and you divide it by the new power. So the answer in the simplest form, just move that in the denominator because it has a negative power. So 1 over negative 4, because 4 times negative 1 is negative 4, x plus 3 power of 1 plus c. Last question on the spot, 4 times 4x minus 1 power of 2. As you see, the derivative is given. Derivative of the expression is 4. So I'll write 4 over the derivative. Then they will cancel each other. Then just you have to add the power by 1. 4x minus 1 power of 3 over 3 plus c, which means the answer is 1 over 3 4x minus 1 power of 3 plus c. Question 7 on the same exercise, because it's related to that we did in question 1. Integration of 2x multiplying by x squared minus 5 all to the power of 3 dx. First of all, you have to check the derivative. In general, you couldn't divide it by the derivative of the expression if that derivative has x or any variable. But you're supposed to divide only by a constant, by a coefficient. So all the questions that we're going to do, inshallah, all the terms that are missing will be the coefficient of the variable. Fine. Integration of 2x, x squared minus 5 all to the power of 3. The derivative of the expression is 2x, and 2x is given to you. So 2x divided by 2x, they will cancel. I know I said you couldn't divide it by the derivative, but just to combine them or just compare the differentiation or the derivative. Then add the power by 1, x squared minus 5 all to the power of 4 over 4 plus c. So the answer is quarter x squared minus 5 all to the power of 4 plus c. Same thing for the g, but you need to move that first to the numerator. So integration of x, 3 plus x squared all to the power of negative half. Why you have to write negative half? Because you have a square root. So square root will be converted to power of half. The derivative of the expression that you have inside is 2x. And as you see, you have only x. So only one missing part. Only one missing part. This is the point that I told about it in the previous question. So only going to divide it by the derivative or the missing part of the derivative. So the missing part is 2. 2 is not given, right? So you have to divide it by 2. So 1 over 2. 1 over, or 1 divided the missing part of the derivative. Then 3 plus x squared all to the power of half, because negative half plus 1 is half, divided by half plus c. 2 times half is equal to 1. So the answer is 3 plus x squared plus c. We can say something else here. If you need to divide x by 2x, then x will cancel x, so only half is left. And then you have to continue as we did. You just add the power by 1, power of half, dividing by half, plus c. h. Now let's move first of all the denominator. So it's integration of x plus 1, x squared plus 2x plus 3 all to the power of negative 4 dx. Derivative of the expression that you have inside is 2x plus 2. Now, what is the difference between this derivative and the expression which is given to you? The difference that you need to multiply that expression by 2. If you multiply 2 by the x, you'll get 2x, and you multiply 2 by 1, you will get 2. So only 2 is missing. So I will do that. X plus 1 dividing 2. Take 2 as a common factor, right? So x plus 1 cancel x plus 1, and only 2 is left in the denominator, which is half. Only 2 is left on the denominator, which is half. Then add the power by 1, x squared plus 2x plus 3 power of negative 3 over negative 3 plus c. Now just multiply the denominator, so it's 1 over negative 6 x squared plus 2x plus 3 power of negative 3 plus c, or you can write that in the denominator, so it's 1 over negative 6 x squared plus 2x plus 3 power of 3 plus c. Question number 8. This question has the same idea of the question number 7 and even question number 1, which is integration by recognition. You have to check first of all the derivative. We spoke about the rule on the first paper. Integration of e power of 3x plus 1. Derivative is not given. If 3 is given to you, so directly you write the answer as e, but the derivative is not given. So you're supposed to divide it by the derivative first. So 1 over 3, because derivative of the power is 3, times e power of 3x plus 1 plus c, and that's it. Or you can write into this form, e power of 3x plus 1, all divided by 3 plus c. Here, you have to move the denominator first by changing the sign of the power, so it's integration of e power of negative x, not plus 1, it's minus 1, because you have to distribute the sign on all the terms of the expression. Derivative of the power is negative 1, so 1 over negative 1, which will give you at the end negative 1 or negative sign, e power of negative x minus 1 plus c, or negative 1 over, if you move the e in the denominator again, x plus 1 plus c, negative 1 over e power of x plus 1 plus c. That's it. Here, first of all, you have to combine the powers, because in case of dividing same bases, you have to subtract the powers. So it's integration of 2 e power of 3x plus 1 minus x dx. Yes. Keep the 2 as it is. Integration of 2 e power of 3x minus x is 2x plus 1 dx. Yes. Now the derivative of the power is 2. So you do 2 over 2 and they will cancel each other, and integration of e will be the same thing without changing anything in the power. Question 9 on the same exercise into page 269. Show that integration from 0 to 1 of e power of 2x minus 1 dx is equal to e squared minus 1 over 2e. This is now definite integration, which means with limits. So you're supposed to do the same type of integration, but without writing plus c. So starting on the left hand side, integration of e, derivative of the power is 2, and as you see 2 is not given, so you're supposed to divide it by the derivative first, so it's 1 over 2 e power of 2x minus 1, and just write the limits from 0 to 1. Keep the half as it is. Now once you have to replace 1 and once you have to replace 0, then you're supposed to take the difference, so e power of 2 times 1 minus 1 minus e power of 2 by 0 minus 1. 2 by 0 is equal to 0. So 2 times 1, 2 minus 1 is e power of 1 minus e power of negative 1. Now you're supposed to make common denominator. It's e over 1 minus 1 over e. Common denominator is e. If you multiply both denominators, e by e is e squared, and 1 times negative 1 is negative 1. Then if you multiply these two fractions, if you keep the answer as it is, it's fine. So which is equal to right hand side, or just multiply numerator by numerator and denominator by denominator. Then it's e squared minus 1 over 2e, which is equal to right hand side. Proved. Now we're going to move to 12.6 that you find in exercise 12e, page 284. Integrals of the type k times derivative of the function over the function itself times dx. That will take you to derivative of len. If you remember, derivative of len is derivative of the function over the function itself. So this will take you directly to integration that will give you len. Here is the rules. Integration of 1 over ax plus b. That will happen only in one case. If the denominator has power 1. Only in case the denominator has power 1. 1 over ax plus b power of 1 dx is 1 over a, because I need to divide it by the derivative. Derivative of the expression is a, so it's 1 over a. Then integration of denominator is len ax plus b, modulus of ax plus b plus c. If the constant is given, so it's constant divided by the derivative, as we did in the previous part, but the only difference, you have a constant here. And derivative of the denominator is len modulus of ax plus b plus c, which means a over ax plus b. So a over a will cancel each other, and you have only the len of the denominator, len modulus of the denominator. Here is some examples. In exercise 12e, question number 1, find integration of 3 over 2 plus 5x dx. Now we're going to ask a question here. Why we supposed to do this for only if the denominator has power 1? See, if you move the denominator by changing the sign of the power, it will be power of negative 1. When you're going to add the power by 1, negative 1 plus 1 will give you 0. But this is not the point. The main point, when you're going to divide, you couldn't divide it by the new power, which is 0. So divided by 0 is undefined. So that's why the integration of any denominator with the power of 1, the expression of the denominator, or the power of the denominator is power 1, is equal to len always. So it's derivative of the denominator, which is 5, isn't it? It's derivative 5. So, and you have a constant. This is the second case. So it's 3 over 5 len modulus of 2 plus 5x plus c, because it's indefinite. So you can write it here one more time. 3 over 5 len modulus of 2 plus 5x plus c, or you can write it as 3 len modulus of 2 plus 5x all over 5 plus c. Same thing here. Derivative of the denominator is negative 2, so it's negative 2 over 2 len modulus of 1 minus 2x plus c. Negative divided negative, negative 2 divided 2 is equal to negative 1, negative len of 1 minus 2x plus c. On the same exercise, question number 6, integration of 3x over x squared minus 1. Yes, derivative of the denominator is 2x, and you have here 3x. So 3x over 2x, x will cancel x, and only 3 over 2 left. So you need to divide by 2. So 3 over 2. Then len of the denominator, x squared minus 1 plus c, or 3 len modulus of x squared minus 1 all over 2 plus c. Derivative of the denominator is 2x plus 1, and the derivative is given, so no need to write it again. Why? Because 2x plus 1 over 2x plus 1 will cancel, and then you have to write len of the denominator, x squared plus x minus 2 plus c, or len modulus of x squared plus x minus 2 plus c. Same thing with the e. Just move the e in the numerator. No, you couldn't do that here because it has power of 1. So derivative of the denominator, derivative of the power is 2. 2 times 2 is 4 e power of 2x. So e power of 2x dividing by 4 e power of 2x, e will cancel e. Then len of the denominator, 4 2 e power of 2x plus c. So the answer is quarter len modulus of 4 plus 2 e power of 2x plus c, or len of 4 plus 2e power of 2x dividing by 4 plus c. Question number 4. We're going to back to exercise 12C again, into page 267 from the textbook. A curve has gradient function k times 2x minus 1 power of 2. This is the derivative. And passes through the origin. You know that the origin has the coordinates 0 and 0 and the point 1 and 2. Find the equation of the curve. If the question asks you to find the equation of the curve, or y in terms of x, or find f of x, you have to understand from the question directly it's required to do integration. And one more thing, in the question they give you gradient function, which means dy by dx or f dash of x or y dash. So since dy by dx is equal to k 2x minus 1 power of 2, and you want to reach to the equation of the curve, so you have to do integration. So therefore y equals integration of k 2x minus 1 power of 2 dx. As we did from the rules, derivative of the expression is 2, so you need to divide it by the derivative first, k over 2, then add the power by 1 and divide it by the new power. So y equals to k over 6 2x minus 1 power of 3 plus c. This is the equation of the curve. But the point is, you need to find the values of k and c. So you're supposed to use 2 points. I'll use first of all 0 and 0, the origin point. So using 0 and 0, 0 equals to k over 6, 2 by 0 minus 1 power of 3 plus c. Then you have to move c to the other side, or just make two simultaneous equations. K over 6. 0 minus 1 power of 3 is negative 1. So it's negative k over 6 plus c. Or you can write it into this form. K or negative k over 6 is equal to negative c. So negative will cancel negative, then c is equal to k over 6. So you can write c in terms of k or k in terms of c. From the previous video, k over 6, let's call that equation number 1. Now let's use the other point, 1 and 2. We're going to use the coordinates of 1 and 2 in the equation of the curve. So y is equal to k over 6 2x minus 1 all to the power of 3 plus c. Y is 2, then keep k over 6 as it is. 2 times 1 minus 1 power of 3 plus c. So 2 equals to k over 6. 2 times 1 minus 1 is equal to 1 power of 3. 1 to the power of a number is equal to 1 plus c. This is equation 2. From equation number 1, we got that k over 6 is equal to c. So 2 equals to c plus c, which means 2 equals 2c, which means c is equal to 1. We got the value of c. Then you have to use c in the equation of the curve to find the value of k. So y equals 2. You have to use c in one of the equations to get the value of k. So I'll use that into equation 2 or equation 1. It's up to you. So 2 equals to k over 6 plus 1. By moving 1 to the other side, so 1 equals to k over 6, using cross multiplying, k is equal to 6. Then the equation of the curve is 6 over 6, 2x minus 1 power of 3 plus 1. 6 divided by 6 cancelled, and the equation of the curve is 2x minus 1 power of 3 plus 1. This is the equation of the curve.